institution coming and joining us. So it's all good. I think it's a great way to broaden our impact and involve as many people as possible. So anyway, we are at 5 minutes after the hour, so let's go ahead and get started. Greetings, everyone. Welcome to another College of Science virtual seminar. I'm Michael Kaufman, Dean of the College of Science. You know that by now. And today we're very excited to have Kate Wilkin with us, one of our new professors in the biology department, and also one of the founding members of the Wildfire Interdisciplinary Research Center. A little background on Kate. She received her bachelor's in biology and environmental science from William and Mary College, then a master's in biology from Cal Poly SLO, or SLO, whichever way people pronounce it these days. So she's a product of the CSU system. And then her PhD in fire ecology from UC Berkeley, where she worked on prescribed burns, lightning-caused fires, a whole bunch of different things having to do with wildland fire, including spending lots of time organizing extensive field campaigns in the wilderness. While she was a student in various places, she was a technician for California State Parks, Yosemite National Park, a range of parks in Maine, also did some consulting with an asphalt company. And after finishing her PhD, while she was postdocing, she worked for the UC Cooperative Extension as a research advisor in 4 large Northern California counties on wildfire issues. As I mentioned, she joined the Wildfire Interdisciplinary Research Center just last year when we formed it. So she's a year and almost a half into her tenure line appointment here, and we're very excited today to hear about her work examining a range of solutions to the California wildfire crisis. So Kate, take it away. And as usual, folks, if you have questions, go ahead and type them in the chat and I'll interrupt Kate as appropriate. All right, there we go.
Sounds great, Michael. Thank you. Hi, everybody. I'm excited to be here today and share some of my research that has spanned pretty much the past decade. I'm looking at the California wildfire crisis and trying to evaluate some of the solutions from the wilderness to the wildland urban interface. And as you all know, California is this beautifully incredible, diverse state with our residents and also our natural wonders. And so when we think about the California wildfire crisis, that also spans this incredible diversity. And so we have to think about solutions for different parts of the state. And I want to talk to you a little bit more about how I actually perceive the wildfire crisis before we go forward. So when I think about the California wildfire crisis, I actually think that we're talking about 2 distinct crises here in California. And they're really overlapping in many ways, but not in entirety. So I like to call them the twin crises. It's wildfire here in California and how that influences our communities, and then also a forest health crisis. We're obviously losing a lot of forests here to both drought mortality and wildfire. And so these are distinct phenomena despite being overlapping, and they have unique solutions. So for the crisis in our communities surrounding evacuations, loss of lives, a loss of property, our communities are being exposed to more frequent and quick moving fires and severe fires than we've ever experienced before. And we've seen this dramatic loss of homes since 2017. So in 2017, 10,000 structures were lost. In 2018, 18,000 structures were lost. In 2020, 17,000 structures were lost. And it's really amazing to think about those numbers because prior to 2017, probably about only 10,000 structures have been lost in California. So we have quintupled the number of structures lost really in the past 5 years. And so this is obviously a wicked problem of living in a fire-prone ecosystem and having people living in those places. And so as a fire ecologist, I like to think about how can we live more sustainably in a fire-prone ecosystem. And ultimately, can these communities take a nod from these fire-adapted ecosystems that actually thrive with fire to be resistant and resilient to fire? The other crisis that I see here in the state is a forest health crisis. And the Sierra Nevada Conservancy had a recent report that said forests from bad to worse, because these forests are set up for disaster, because we've suppressed fire for well over 100 years. And there's such intense competition between the trees that the trees become really stressed and susceptible to a wide range of threats. And the extreme drought we had recently pushed many of these stick trees over the edge and they died. And so we have increased fire, insects, and disease, and they're all a symptom of the same problem, which is tree density and a lack of forest management. And there, there's some pretty broad consensus among policymakers and managers and scientists that we need to reduce the number of our trees in our forests, and people are taking action on public and private lands. And so I want to talk to you all a little bit about what are the actions that people will take in the wilderness. And so today I will be trying to talk about two main types of solutions. And so one is wilderness fires that consume fuels in mild weather. And then also structure mitigation. So how can we protect structures from wildfire? Okay. And so while the California Wildfire Crisis and the Forest Health Crisis are both really broad topics, as a scientist, my overarching research questions really is focused on how can we manage ecosystems to foster our human values, such as fire adapted communities, resilience to climate change, and these provision of ecosystem services. And as an ecologist, my focus has been primarily on how do plant communities influence fire, and how does fire influence these plant communities? And so I worked on these issues across the entire landscape of California, from wilderness areas in the High Sierra, through our foothills into the Central Valley, and also in our wildland urban interface. Throughout all of these areas, I've had a few different research threads. So one has really been focused on pyrodiversity and biodiversity. I'm going to be sharing some of that with you today. Another thread is on fuel hazard reduction, and I'm going to share a little bit about that as well. And then lastly, these ideas of fire adapted communities and how we can live more sustainably as communities within these flammable plant communities. So let's start off here in the wilderness areas. And in these wilderness areas, I was really interested in studying pyrodiversity because we recognize that these areas, lots of California used to be pyrodiverse because we had cultural ignitions from the people who lived there. We had lightning ignitions, and these ignitions happen throughout the year. And a lightning ignition might happen during a summer thunderstorm, and it would, smolder in the top of a tree on a hot, windy day. Those embers would be cast out, and then the fire would roar up mountains, consuming lots of fuel when it was hot and dry. And then at night, it might smolder or move very slowly. And that fire would really only be put out when there was a sufficient snowfall and sufficient rain. But ultimately, we recognize that these fires happened at many different intensities in California's forests. And not only that, but they happened over these broad time spans. Ultimately, now in California, it's actually really difficult to find a pyrodiverse forest. But there are a few places. And so managers were first comfortable letting these wildland fires burn in the wilderness in the early 1970s. And they were generally areas that were remote and surrounded by granite mountains, because they were really nervous about testing these new ideas. And so they started off here in California, but they expanded to the Boundary Water areas, the Gila Wilderness in New Mexico, the Bob Marshall Wilderness in Idaho, and even further afield now. And in these wilderness areas, I want to share with you all the benefits of allowing these fires to burn. And so I'd like you all to come with me today on a quick backpacking trip to Yosemite National Park and also Kings Canyon National Park, where we can witness some of the observed natural experiments that people have been working on for many decades. Okay. When you walk into these sites, it's often 3 to 5 miles to get into these research sites. And they're throughout the mixed conifer forest from about 5,000 to 8,500 feet in elevation. Some of the tree species that you might see here are Jeffrey pine, lodgepole pine, white fir, and red fir. And so the Illilouette Creek Basin and the Sugarloaf Basin are both natural experiments. So here, like much of the US, fires were suppressed beginning with the Yosemite Cavalry in the 1880s. And that extended until the 1970s. However, in the early 1970s, there were a few very brave park rangers who understood the importance of fire in the system, and they allowed lightning strike fires to burn freely. And so these fires smoldered and creaked and roared, and only really, like I said before, were extinguished when snow fell. And today, there have been more than 50 fires which exceeded 100 acres with mixed severity fire. And early studies suggest that the fire regimes which were restored is demonstrated here in an infographic. So let me share this with you here. So you can see since the 1970s in the Illilouette Creek Basin, we've had all of these different fires, which are these colored polygons that have burned from lightning strike ignitions. And they've started to fit together like a jigsaw puzzle. And this is really amazing because what this is showing is it's showing us that, these fires become self-limiting because a fire is consuming the fuel and it's limiting the detrimental effects of a future fire. In addition to seeing this self-limiting effect in the system, we also see that the frequency and the extent of fires is approaching what occurred historically. It's not quite the same frequency as occurred as historic records show from tree scars. And that's likely because this area is not having any cultural ignitions. The Yosemite Miwok used to burn this area regularly, and now that's not happening. But this is still one of the best areas that we have for studying these ideas of pyrodiversity and these observed natural experiments. And so here we're looking at two classified images of the Illilouette Creek Basin. And so on the left here, we see what this region looked like in 1969 when the program, this wildland fire use program, was initiated. At that time, I have to admit, it was called Let It Burn. And then in the 2000s, it was called Wilderness Fire Use. So here in 2012, after 40 years of burning, you can see that the texture of these two image classifications has really changed. We went from a homogeneous forest in 1969 because it lacked management. And after 40 years of burning, we see that there's lots and lots of different types of forests and plant communities near one another. You have to really squint to see the patterns, but it's just really impressive to see how much restoration that fire was able to do on its own in this system. So I would say it was a herd of undergraduates, I should say, that created these images. There's about 20 undergraduate students who worked on this image classification project. And then in addition to showing these changes through time, we were also able, through aerial images, we were also able to show that across the landscape, there was dramatically reduced fuel loads. And so we did intensive field work counting sticks throughout these forests to show that the fuel loads have been dramatically reduced by these fires. And then in addition to restoring this forest structure and reducing fuel loads, other work by Gabrielle Boyrami and Sally Thompson also showed that you could restore stream flow. So they show that there is a dramatic increase in stream flow downstream after the initiation of this wildfire program. It also shifted the stream flow timing to be slightly earlier, and it reduced the water stress in the forests. And so ultimately, as part of this really large interdisciplinary team, we were able to show that you can restore forest structure with these methods, reduce fuels, increase water, which seems particularly important this year in California. So those are some three main huge benefits. As an interdisciplinary scientist, I contributed to all of those projects, but I also had some projects that I spearheaded, and my project really focused on biodiversity in this region. So I wanted to show you a few pictures of what these natural areas look like. So here's a classic stand of large white firs, but not all forests look like this, like a park-like stand. Rather, they're heterogeneous, a little bit of this and a little bit of that. And if you start to look underneath the charismatic megaflora of the forest, you see these amazing understories with lots of grasses here. or some shrub fields, which are part of our forest system, although in areas that are, 10 or 200 or 300 acres. These shrub areas were obviously very difficult to access in terms of researchers. You probably can't see it, but myself and two other research technicians are somewhere underneath Megan here collecting data on plant diversity. But what I can say is that these areas actually do have quite a lot of plant diversity. And here's another area of the Illilouette Creek Basin showing how a lodgepole forest is gone, and what we see now is a wetland. And this type of wetland actually is very important in terms of water yield in the Sierra Nevada. Okay. But anyways, the series of photos just really demonstrates how this environment is changing through time and the importance of fire at fostering these different communities. And as I worked on this interdisciplinary project, and I recognized that the patterns of fire around the plots influenced what was in the plot as well. So it wasn't just what I saw on the plot, but it was also what was nearby. And ultimately, this is called pyrodiversity. And so as a biologist, most biologists think that diversity begets diversity. And there were a few fire ecologists, Martin and Saxis, who outlined the mechanisms for how fire could influence biodiversity. And they coined this term pyrodiversity. And they went on to say that it could influence biodiversity. However, up until my recent work, it was really poorly understood because there were so few areas that actually were pyrodiverse to test some of these ideas. And so when we think about pyrodiversity, it has to do with the season, the severity, the extent, the frequency, and any compounded disturbances that might occur, like drought or cold snaps and those sorts of things. And when we think about how these might influence diversity, season alters the potential colonizers and species response to the disturbance. The severity of the disturbance, or how many trees died, could either kill trees and then release seed banks and other vegetation. The extent of a fire alters dispersal capabilities of species. We recognize that most conifers can only disperse about 200 meters. The frequency of a fire also has a selection pressure. It selects for climax or early successional species, or species that are resistant or resilient to fire. And then lastly, compounded disturbances. And so a diversity of fire regimes increases the range of potential compounded disturbances such as disease and weather events that occur. And ultimately, when you have pyrodiversity, the hypothesis is that it contributes to biodiversity. And so this was an interesting research question to tackle because, first of all, not only are there so few pyrodiverse areas here in California and more broadly around the world, it was also hard to tackle because how can you integrate this idea of these different types of a fire experience to understand how that might influence diversity? And so I worked really closely with my colleague, Lauren Panicio at Berkeley, and we came up with this idea of, so the diversity of your fire experience, so how long ago did you burn? How severe was the burn? How many times did it burn? And we really tried to quantify the fire diversity with a single metric, whose pattern can be analyzed at a landscape scale. And the metric goes really well beyond, is it a high severity patch where a lot of trees died, or is it mixed severity where some trees died and some trees didn't? And so we try to synthesize these spatial variables like fire year, fire severity, number of times burned. And then we made a sandwich out of all of this. And so here, this is the Illilouette Creek Basin and the fires that occurred in 1994, 2001, and 2004. Here is an example of one of our plots that has a unique fire history. So in 1994, it burned with low severity, moderate severity, and then low severity again. We have another plot that is unburned in 2004 and 2001. At very low severity, and then in 1994, low severity. And so these severities are just looking at how many trees are dying. And so we synthesized all of these together, And we came up with this index of fire history from rare to common fire history using a number of different common diversity metrics like Simpsons and functional divergence. And what we ended up with was this landscape-wide biodiversity metric. And so here you can see the metric going from rare to common, and you can see some of our plots. And so here's a plot with the buffers surrounding it at 25, 50, 75, 100, and a 250 meter buffers. We looked at common metrics, like I said before, like functional richness, functional dissimilarity, functional divergence, and Simpsons, to see what types of metrics actually were really important for plant biodiversity, amongst other fauna. And so the benefits of this type of metric is it captures multiple aspects of fire history that contribute to fine scale heterogeneity. The biodiversity can be calculated at many different scales. And ultimately, we tested this looking at plots within Yosemite and Kings National Parks. And so when we looked at richness, we included many different types of variables in our study about the environment and about the fire history within the plot, and then also the fire history surrounding the plot. And what we found for richness was the model that had the lowest AIC score was a reduced model that included the climatic water deficit, which is looking at the ratio of water that comes in versus the amount of water that plants will evapotranspirate. And then the functional divergence within 50 meters of a plot for moderate severity fire, and also soil texture. So let's start on the left panel here. So richness is on the y-axis and climatic water deficit is on the x-axis. So here the solid line is a regression estimate and the shaded area is a 95% confidence interval. And you can see here that the climatic water deficit increases and then plant richness decreases. In the next panel, we'll examine the relationship between biodiversity and fire severity. And here we're going to be looking at functional divergence. And functional divergence is how different are the experiences. And as differences increase, so does functional divergence. And so here, what I'm showing you all is when functional divergence is increasing for moderate severity fire, we see that there is an increase in plant richness. And lastly, soil texture. Soil texture also influences plant richness. Ultimately, while all of these influence plant richness, we saw that only one of these had a really large magnitude of influence on richness, and that was the functional divergence within 50 meters for moderate severity fire. And so ultimately, looking at these research results, it's an interesting combination because climatic water deficit says that the environment matters. Biodiversity matters because functional divergence mattered. We also know that recent fire history mattered because, moderate severity fire had a different interaction with functional divergence than low or high severity fire. But overall, we do see that the biodiversity had the largest effect size. And so from my research, you can see that biodiversity is important in the Sierra Nevada frequent mixed conifer forests, frequent fire mixed conifer forests. And so the understory, the scale of influence that's most important at fostering diversity is at 50 meters. That fosters the highest diversity. For pollinators, the scale is about 150 meters. And we also recognize that the interactions between plants and pollinators is also important at the scale of 150 meters. Since coming to San Jose State, I've continued conversations about biodiversity with Lauren Panicio, who is a co-author on these papers, and many other people in Western North America who are interested in biodiversity. And so right now we're working on a synthesis paper to think more concretely about what are the next steps in kind of testing some of these biodiversity theories as a team. And obviously, my work here focusing on diversity was part of a large interdisciplinary team that looked at fire, water, and biodiversity. We recently published a paper as a team about a possible triple win for fire, water, and biodiversity, looking at these natural fires. in these areas. And it was really exciting to think about that as a team, as an interdisciplinary team, we spent more than a decade working on this project, and we were really able to show evidence of the benefits of this natural fire. That people started off in the 1970s as let it burn policy. And it was really exciting because a lot of our research really helped propel the expansion of this policy amongst lots of other research out there to Forest Service lands and other areas. And this was really exciting because many of California's forests are roadless. And one of the only tools that we have in those areas is fire. It was rather ironic this past year, the same week that this paper was published, the Forest Service changed its let it burn policy following criticism from politicians. And it was really a major setback in my mind and in the mind of many of my collaborators on these projects. The week prior, the Tamarack fire near South Lake Tahoe in Markleeville occurred, and it went out of bounds. It was a wilderness fire that they allowed to burn, and then they were unable to keep it within the box that they had designed. And it did burn a few homes, and because of that pressure, because of pressure from that event, amongst other things happening in California, the governor, past Cal Fire chiefs, and others really put a lot of political pressure on the Forest Service to stop this policy. And it was unfortunate because they didn't just stop this policy in California in areas that were experiencing poor conditions for fire, but they stopped this policy across the entire US. So in Florida, in Maine, in the Southwest, that was just coming into their fire season, their like kind of their good natural fire season. And so it was really upsetting to a lot of people that we were in such a pickle because we haven't allowed fires to burn, and now we're not going to allow fires to burn. Ultimately, our team of scientists and many other scientists and managers think that there's still a lot of potential to use wilderness fire. And people are going to be continuing efforts to observe the pros and cons of this type of fire here in California and also throughout the US. Now we're going to take a really big jump from wilderness areas to communities, and specifically home ignition zones. So when I think about fires here in California, catastrophic fire damages such as structure losses are often due to embers penetrating buildings and direct flame contact and radiant heat. And I suspect all of you all here are experts on some of that. I think you all have roasted marshmallows before, am I right?
Yes.
Okay. Anyway, so when we think about fire in this home ignition zone, it's really thinking about all of the fuel on and near structures. So that's on the structure and also in the landscaping around it, and the factors in that area. And this is about 300,000 hectares in California, but it's really poorly understood. And so I recognized how poorly understood it was when I worked for the University of California Agricultural and Natural Extensions. And part of my job as a regional fire advisor was to help these communities become more adapted to living with fire based on scientific recommendations. And a lot of the information that we had was based on post-fire observations rather than joint inference from many different lines of research. And ultimately, I recognized that we really need to be thinking more concretely about how to understand the fire ecology of these home ignition zones. And so my goal is to understand how these landscaping ecosystems, including the plants and other materials, contribute to extreme fire hazards. And so I hope to improve the basic understanding of these home ignition zones, to train students and also educate the public through this project. I'm excited that I'll be starting this project with the Wildfire Interdisciplinary Research Center team here at San Jose State. I imagine hopefully in 5 years or a decade, much like my team at Berkeley, we're going to be putting out some major papers that help move policy forward here in California and around the world. And so here, we have Amanda Seichowitz, who's a sociologist, Ali Tuhidi, Craig Clemens, myself, Adam Kachansky, Miguel Valera is not pictured here yet because I don't think he could get into the country at this time, and also Patrick Brown, who I think is here today. Hey, Patrick. And so as a team, we have a lot of different skills. So, fire. I'm a fire ecologist. We have meteorology, combustion, remote sensing, social science, and also fire behavior modeling. And as a team, we were recently awarded an NSF Industry University Cooperative Research Center grant, which I think will be a potential source of funding for the project I'm going to share with you all today. It's also a source of inspiration for the types of questions that I can ask in this home ignition zone, because a lot of the questions I want to ask here go well beyond my expertise. But when I work with a social scientist or a combustion engineer or someone who does remote sensing, it really allows us to tackle this wicked problem that can't be understood by one discipline. It has to be interdisciplinary work to really help find some of these solutions. Okay. And so here is an example of a home ignition zone. And so is there anything we can do to mitigate danger for the structure as large wildfires become more frequent and the risks for all structures are increasing in California? And so looking at this house, which is actually my old house where I lived in Grass Valley, California prior to starting here at San Jose, like many of California's structures, it was at high risk for wildfire, even though we followed many of the recommendations, both public policy and the latest science. And you can see here that my landscaping didn't look quite like Sunset Magazine, in part because I was a busy working young mother, but also in part because I was trying to follow recommendations on the type of fuel I should have around my house. So no fuel within the 0 to 5 foot zone. So no grass, no plants, no foundation plantings. And then in my 30 foot to 100 foot zone, I also wanted to be very clear that it was lean, clean, and green. But ultimately, some of the things I just told you all about what some of the recommendations are for these zones are based on field observations after fires. They're not really systematically tested. So, could I have more plants in my yard and be safe? That's a question that I didn't actually know the answer to. It's a really important issue. And so when we think about structures and structure ignition, I just want to take a little bit of time to tell you about how structures ignite so we can kind of understand why this zone is so important. So if you have a structure, it's going to be receiving embers from a fire for about half an hour prior to a flame front getting there. And then you'll have a fire front where it's really hot and there's potentially huge flames from plants burning. And that's going to last about 15 minutes, even in a forested system. And then after the flame front, for another 5+ hours, those areas are going to continue to receive embers. And so based on this timeline, we recognize that embers are a major component of things that we need to be worried about. And embers can ignite a house or a structure directly by penetrating attic vents, or indirectly by landing on mulch that's next to the foundation base and igniting the mulch, and then igniting that flaming mulch ignites the house on fire. And ultimately, that's the mechanisms of how structures ignite. And broad research shows that structural survival is influenced by a combination of factors, including the structure, site location, design features and materials, and also defensible space. And while all of these factors influence the likelihood of a structure's survival, the relative importance of these features decreases from the structure outward. And even site location, people believe, can be overcome through other pathways of wildfire mitigation. And so these sorts of structure design features are some of the structure features are regulated by the state of California. There was a 2007 California Building Code amendment, and then more recently there was another code to further regulate the materials around a building and also in the defensible space zone. So, looking at this house, that was my house in Grass Valley, I had a lot of personal experiences trying to apply recommendations from CAL FIRE, from the National Fire Protection Association, and also some of the latest science from a research lab at the Insurance Institute for Business and Home Safety. And I also had a lot of insight from talking to the general public as a UC A&R fire advisor. I was often asked to talk about, how can I prevent my home from being lost in a fire? And so people wanted to know, what plants can I plant in my yard? How do we maintain them? How wide should I make my garden path? And anyways, these are some of the questions that people asked me and that I had myself that really catalyzed this research. And so to really tackle this problem, I'm interested in a range of spatial and temporal scales that others have made recommendations on that for either overall defensible space or like plant lists. And I just want to start tackling these sorts of scales that people are interested in and have made recommendations on prior, because we really just don't have a lot of joint inference about, what actually could work in these situations. So, one scale that I'm really interested in is this home ignition zone ecosystem. So all of the abiotic and biotic factors that you see here. So that would be, the house itself, any trash cans that might be near it, the plants, and their arrangement. I'm also interested in the structure of plants. And so here we have a tree. How would this be different if it had multiple stems or other factors that influenced how easy it was to maintain, or how easy it was for fire to climb up a ladder of plant fuel to get to the canopy? I'm also interested in the scale of a leaf, because that can really tell us a lot about flammability in terms of igniting from like hot temperatures around a fire. And in terms of time, I'm really interested in the fire season, so oftentimes May to October, and how fuel moisture and litter deposition might change year to year and throughout the season. And then also, what happens on a red flag event? So a red flag event might be an extreme fire weather day, or even a purple flag event where we have those extreme phone winds or the Diablo winds that we have here, or the Santa Anas, or all of those wind events that have really contributed to many of those large loss of structures that we've had. Okay. And so thinking about what is currently out there. So currently CAL FIRE has a fire resistant plant list. And so here are some of the plants that are on that list. And I have to say, when we think about, what do we know and what are the fine scale specific actions that residents can take, there's very limited to no systematic data collection for things that might be fire wise or fire smart or even fire resistant. So for example, looking at these plants on the CAL FIRE list, we have French lavender, which is lovely to have in your yard, but it's also quite flammable because of those beautiful like aromatic smells of the volatile organic compounds. And then furthermore, it can also be detrimental to have in a yard because this plant, if you cut it back every year in the fall, then it stays herbaceous and non-woody, and there's very little dead fuel in the center of it. But if you let it get bigger and bigger and bigger, then the interior of the plant is entirely dead, and it has lots of fine fuels for those embers to ignite. And so, French lavender, I think, made the CAL FIRE list because it has high fuel moisture, but they didn't take into account some of those other issues about the plant's structure or the compounds that were in the plant. Another example of a plant that I hope to evaluate for my studies is a yellow ice plant. This is another plant that has incredibly high fuel moisture. It's a succulent plant. The water, like if you press the leaf, water is like oozing out of it. But it's interesting because if you look underneath this plant, you actually see a lot of brown thatch. And that's because when this plant dies, it gets a little bit woody and it dies on the underside, and you end up having this bed of perfect fuel underneath the ice plant with this green wet blanket on top. But when an ember comes floating through, it's going to land on the brown litter bed underneath and ignite that. And so these are just, two examples of things that are on the CAL FIRE list that if we were to do a systematic evaluation of these plants, from the leaf to the whole plant to the compounds, that probably wouldn't make a fire-resistant plant list unless you were given clear guidance on how to maintain them to be fire resistant. And so really, instead of having a fire resistant plant list, I would say that we really need to be thinking about how, not here's a list of plants that you can plant, but here's a list of plants that you could plant, and this is how you maintain them. So kind of the right plant, right maintenance. And not only that, there's some plants that we may not want incredibly close to our houses, like the lavender. It has a lot of aromatic chemicals, so it can actually burn fairly hot, especially if it's not maintained well. And so it could be right plant, right place, right maintenance. And so moving forward in the next 2 to 5 years, these are some of the things that I hope to evaluate surrounding this home ignition zone, with sources of funding from both my startup funds, the Wildfire Interdisciplinary Research Center, industry, university cooperative, and other sources of public funding. So I want to look at common horticultural plants and their fuel moisture and their leaf traits, their fuel arrangement and amount for living and dead materials, and experimenting with irrigation and pruning. I also want to look at the fire behavior of leaves and litter in the entire plants, so we can really understand how easily these plants ignite, how much heat they release, how tall are their flames, and then also how long do they flame, because that could really tell us, could they possibly ignite a house? And then for the home ignition zone ecosystem, I'm interested in the plant composition. This is, again, 300,000 hectares of California. So it would be nice to know what's there. And also, if we do have defensible space, how is that for native plants versus noxious weeds? I'm also really interested in the fuel composition here and the fuel moisture of a home ignition zone in situ. And then I hope to compare these home ignition zones for unique community archetypes. Obviously, this goes beyond my expertise, and it really works with everyone at the Wildfire Interdisciplinary Research Center. And so most of what I have just described for the home ignition zone, I would say, is future work that I'm working on scoping right now. But I do have students right now, some are present here today, who are working on describing the fuel moisture of horticultural plants on campus. And so we're, going around to some of these common places that you all see. Can you all recognize any of the pictures here where we're doing our field work?
Yes, ma'am. A lot of them.
A lot of them, right? So here, we have the National Gate, we have the Student Wellness Center, we have other gates, we have the ATM machines with these Mediterranean cypress, and lots of other places on campus where we're trying to understand the fire ecology of these common horticultural species. And so with the team of students, we've identified plants from unique functional groups across campus. So looking at things that are evergreen or deciduous based on their growth forms. So are they a grass, are they a herb or a shrub or a tree? And then also, do they have volatile organic compounds? And so we've been working really closely with Brian Bagley from Campus Landscaping, and he's been a real pleasure to work with. And he has been helping us understand how we can complete this research here on campus. And so here's a picture of Brian and Arthur looking at heavenly bamboo to see about where you can prune the heavenly bamboo to collect the leaves to understand their fuel moisture, but also to make sure that it's still aesthetically pleasing for campus and that we don't do any harm to the plants. And so we've been running our fuel moisture work now for almost 3 weeks, and I'm really excited about our preliminary results so far. And I'm excited about our preliminary results so far, in part because a lot of the recommendations for how to design a fire-wise or fire-resistant plant list all came from the Southeast, where they often have fire seasons that are unique from here in California. And so in California, I would say that we have 2 distinct fire seasons. One is a summer season that kind of peaks in late August or early September, which is driven more by heat and dryness. And then we also have a fire season in the fall that is more wind driven. And during this wind driven time period, which I would say is October and early November, when we had a number of our catastrophic fires occur, we've noticed that deciduous trees have incredibly low fuel moisture. And their fuel moisture is even lower than evergreen trees on campus. And that's a real interesting factor, because oftentimes a lot of plant lists say, deciduous trees are safer than an evergreen tree. But for Californians, when our fire season coincides with this leaf excision process, when leaves start to go dormant and they still look green and healthy, they've actually already started to reduce the amount of water in their leaves, even before they've turned colors. And then they turn colors in fall. And obviously the falling of leaves also coincides often with this wind-driven fire season. And so, this research obviously is very preliminary data. It's based on 3 weeks of sampling that we've done as we initiated data collection, and then more research is going to be needed to hold these trends. But I actually suspect, just based on my personal experiences, that this might really hold up in California, that we might need to give caution to deciduous trees in the wildland urban interface. I know from my personal experiences, I lived in Grass Valley during the Camp Fire, and during that wind event, I had cleaned off my roof and my deck and around my house prior to the wind event, because I knew that it could be a big day. And when I woke up the next morning and the campfire was burning, 25 miles north of me, I was able to collect 3 entire leaf bags of black oak leaves and ponderosa pine needles that had just fallen on my home from trees that met the guidelines from Cal Fire and the Insurance Industry for Business and Home Safety, Builders and Home Safety, and also the National Fire Protection Association. So I recognize that, those wind-driven fires, we know that there's a lot of litter deposition during that time period, and also that plants have really low fuel moistures, even deciduous trees. So hopefully this time next year, we'll have more conclusive things to share with you all about that topic. And so today we've talked about, scientifically evaluated solutions for California's twin crises of wildfire and forest health. First, I talked about evaluations of wildland fire use policies and the benefits of it. I also shared with you all a framework for science-based home ignition zone landscaping suggestions for Californians. Obviously, these topics are tied together through the complexities of the wildfire crisis here in California. And both of these projects couldn't be completed by myself alone. They were completed amongst so many great collaborators and organizations. So just a really big thank you to all of these people who have helped with so many of these projects. Okay. And do you all have any questions or comments?
Thanks, Kate. I have 2 for you.
Okay.
So one of them is just a clarification point. So when you were talking about how the fact that fire had gone through that region over a series of years, it improved the what was the word you used? Hold on a second. The water yield.
Mm-hmm.
So what's the mechanism by which the more diverse plant life provides a higher water yield?
That's a great question. And so when we think about the more diverse plant life, the link between diverse plant life and water yield, in the Illilouette Creek Basin, that area historically was a matrix of forest and wetlands and shrublands and grasslands. But through fire suppression, tree density increased across that entire landscape to the point where shrublands were lost and most wetlands were lost. Okay,
so the ability of the land to just hold the water went way down.
Right, the ability went down because especially with the trees in the wetland areas, the trees consumed quite a lot of water and they dried those wetland areas. So that water couldn't percolate into the groundwater. It was that was an interesting study to work on, because in areas that are shrub, actually you see a decrease in water yield. for the whole system, but because the increase for water yield is so dramatic from the wetlands, it actually the net effect is a gain.
Got it. Yeah, so it's not a straightforward. There's a bunch of different competing factors going on at once.
Yeah.
Cool. All right, I have another question for you, but I'm going to let a few other people ask questions first, and then I'll come back around to mine. It looks like Jean Beard has her hand up. So Jean, if you unmute yourself, you should be able to ask the question yourself. There we go.
Hi, I just wanted to comment. It's more than 50 years ago since I arrived on the campus. So my perspective is different because the campus is different in part. But in studying the history of the campus, I learned that the land that the original campus, that's San Carlos to San Fernando and 4th to 7th Street, was a pretty lousy plot of land, and they had trouble growing things on it. But what they worked hard at was to have native plants. So they planted a lot of native plants. The last time I paid any attention to it, the ones that were left were largely near the memorial.
Mm-hmm.
Many of them are long gone. But
so the redwoods that are by the memorial, for instance?
Yes, the redwoods,
Mm-hmm.
but on the other side, there are some other deciduous trees that are natives as well. And don't ask me, I'm not going to give you a lecture on it because that's a long time ago. But in any case, there's some of that left, and I don't know whether that has any bearing on what you're doing, but I thought you should know. And there used to be a map that FDNO had that was literally listed all the plants on the campus. And that may or may not still exist, but it might be useful. And I thought you ought to know about it. I think this is very interesting, and I commend you on what you're doing. But I just wanted to give you a little ancient history to go with it.
I appreciate that. Yeah. So right now, the students who are sampling both native and non-native plants that are on campus. So Jordan, who is present here, is actually sampling some redwoods, although they are closer to the National Bank gate. And then we're also sampling things like Muhlenbergia origens or deer grass and the Rosa californica or the California wild rose, the Quercus agrifolia, the coast live oak. So we are trying to do those native species. I'm also really excited about bay trees, the Umbularia californica, because they're a beautiful tree. They smell delicious and they burn hot as hell. They burn because of the volatile organic compounds. But they're so beautiful.
Elm Rock Park used to have a bunch of them. I don't know if they still do. Anyhow, thank you.
Thanks, Jean.
And then in terms of the map, I've gotten some information. So there was like a 1990 report from somebody in the biology department about trees. And then we've been working with landscaping, and they did not have a map they thought would be helpful. So I don't know if it has been lost.
I don't know whether Rod Myatt is around anymore. Rod would be the one I would check with.
Rod was on this call earlier. It doesn't look like oh yeah, he is still here.
Okay.
Here, I'm gonna open up Rod's mic too. Rod, if you unmute yourself, you can join the conversation. There we go. Rod, are you there? Well, he's unmuted himself, but I can't hear him. So, well, not really sure.
Okay. But
so maybe he's having microphone issues, but well, Kate, I'll make sure that you get connected with him.
Okay, great. Thank you.
All right. Next up is Bill DiVincenzi. Bill, go ahead and unmute yourself.
Thank you, Michael, and thank you.
Oh, I did it again. I keep doing this. I apologize. Yeah. Let's try this again, Bill. My bad.
Okay, can you hear me now?
Yeah, there you go.
Thank you, Michael. Then thank you, Kate, for a great presentation. So I live in a community in East San Jose that has quite a significant urban wildlife interface. In fact, my particular village is 70% surrounded by urban wildlife interface. And we've done a lot of studying, and there's obviously a lot of concern because fires can come at us from any direction. One suggestion that some folks had was perhaps cattle grazing as a means of fire suppression. Sorry for the clock. My main question, though, has to do with funding. Are you aware of any sources of funding, either from the county, the city, the state, that might help us out here? Because they're talking about hundreds of thousands of dollars to clear out, all that foliage around our community.
Yeah, so I'll do two parts. One, cows are really great at eating grass. So if you have a lot of grass, cows will be great. If you have shrubs and trees that also need to be cleared out, you might need to hire people to mechanically thin them with chainsaws and then use goats to kind of suppress it.
Okay. Yeah.
So you have to use the right tool in the right place, and it might be a combination of tools depending on the type of vegetation that you have. And then in terms of funding, there's a lot of great funding opportunities right now here in California. So one is the Cal Fire Forest Health Grants. It's called a Forest Health Grant, but it's actually like anything grant, any kind of land in California grant, and you can use that to protect communities. Oftentimes that grant is submitted through your local fire safe council, so the Santa Clara Valley Fire Safe Council. Other opportunities could be through the Natural Resources Conservation Service, or the NRCS, and that's a cost share program. And they can work with HOAs on that.
Okay. Yeah, we're an HOA, so.
Mm-hmm.
Okay, thank you, Kate.
You're welcome. But so those would be the two pathways that I could think of right off the top of my head.
Cool. Vita. And I'm just gonna go ahead, Vita. Do you want to point out to Kate the other thing you put in the chat right as our talk started?
Oh, you're William and Mary alumni.
Oh, yes, and also I live in the urban wildlife area, definitely. Dorrington, which is above Arnold, which is
Okay.
yeah, and Calaveras Big Trees State Park is between us. But
Yeah, an area that I love to vacation in.
Oh, well, come and see us. We have guest rooms. And I wanted to thank you for your presentation. I think it was really wonderful. The other thing I wanted to mention is that the botany department used to work with basically landscaping, choosing trees to put around campus. And they used to have a field guide in their materials that the students used where they had to learn how to identify these. I wonder if any of that might be of interest to you. And the other thing that you didn't mention, and it's really probably not within your research area, is how houses are built and what materials are used. For example, we have what we hope is a fire resistant outside of on our house. It's cement fiberboard rather than wood. And we've closed in the eaves and we've closed in the vents and all that kind of stuff.
So, I've done that too. Yep.
Yeah, I was thinking you'd be familiar with it. That's another whole aspect of this, which is probably well outside your research area, but I did want to mention it.
Yeah, absolutely. When I worked for UC A&R as a regional fire advisor, I often did a lot of outreach about home hardening and defensible space both, and how it was a good coupled system, how you needed both to really increase the probability of a structure surviving. And it's really interesting because it's not just the materials when we think about a structure surviving, it's also how it's maintained. So making sure that you don't have any gaps in your garage door, making sure that all of your windows are caulked and your siding is caulked, all the things that are really monotonous are also just as important as the materials. Because I've seen many metal roofs, which are obviously very resistant to fire, but they don't have their bird stops at the end. And that's a perfect place for an ember to go in. So even though they had a fire resistant material, the house was really exposed.
Yeah. Thank you so much.
You're welcome.
Thank you for your presentation. Very
and so all that's left is the roof in that case, right? When the house burns down.
It's just like crumpled melting metal.
Right. Yeah. Okay, let me just make a couple of adjustments here. It looks like we got Vita. Okay, I'm gonna lower some hands and lower some hands. Roy Akuda. Roy, go ahead. You should be able to turn on your mic now, Roy. There we go.
Am I here?
Yep.
Howdy. Boy, nice to see Gene and Vita and Rod here. My goodness, I haven't seen her for ages. That's great. Hi, Kate. I have a half-written email to you from about 3 months ago. I've been meaning to sit down and find a time to chat with you. So I'm the resident plant natural products chemist here. So
Okay.
my students and I study California native plants for their potential of bioactive natural products. And so there's some potential areas of mutual interest here.
Yeah, it would be
Like
great if
let's find a time to-
it would be great to chat more, especially about common horticultural plants within the region and looking
Yeah,
at
that was
looking at their
really
volatile organic compounds. Like that, it would be really
Yeah.
great to if you
Yeah.
could, if you were interested in quantifying those.
right. So that piqued my interest. Really surprising about lavender that's on that list, because those terpenes are really, really flammable.
Right.
That's
And I can't
yeah.
wait until Ali has a combustion area we can like burn the lavender also, because I feel just like you have to
Right.
put it all together. You have to have a joint inference to really persuade policymakers, but also to persuade residents to actually take the actions.
And we could take it even further. We could analyze exactly what's in there
Mhm.
and tell you what the chemicals are. And most of them probably it's well known that they are flammable and their potential for use. One of the things we do, by the way, is we grow fire followers. So Lars has helped us grow Eminenti penduliflora,
Mhm.
which I'm sure you know. We have some growing in the greenhouse right now, and we've managed to germinate it, and it's growing quite well, actually. So
Awesome.
we're really interested in maybe looking at some other fire followers as well. So,
Is that in terms of the compounds that induce germination, or?
we use gibberellic acid to get it to germinate.
Mhm.
And what we're interested in is if there are any chemicals in there that are potentially novel in structure, but more importantly, whether they have some biological activity
Got it.
and can be used as potential pharmaceuticals, for example. So, but I know there are other plants like that out there
Mhm.
as well, which we've done literature searches and there's no literature on this at all. So, so that's our approach to
Mhm.
look at these plants. So
Yeah, that sounds
anyway,
incredible.
I'll send you a message and let's find a time to chat.
That sounds great. Nice to
Okay.
meet you, Roy.
Sure, we'll do.
So Abe Walcott posted a question and it looks like he dropped off. So I'm going to try to summarize it. What's the percentage of all fires historically that are caused by natural events versus, human caused? I don't know if there's a good answer for that. I assume most fires historically
What
are.
time frame?
Yeah, that's it. Let's see. Yeah, I mean, he just said historically. He was asking before that about the PG&E PG&E fires versus naturally occurring events.
I mean, like back when there were native Californians here in California, we had somewhere between in the late 1700s, early 1800s, somewhere between 2 and 10 million acres burned every year.
And that was intentionally burned.
That was through lightning strike or through cultural burning.
Right. Okay. But you don't know the mix.
I don't know the mix.
Yeah. And I'm not sure anyone does.
And I don't think you could know the mix, because the only thing we can say is that areas near villages often had higher fire frequency than areas further away.
Mhm.
But we just don't know the mix.
Right. Okay. And I'm gonna ask one more thing, and maybe this is a discussion question for happy hour, but all of the issues that you raised before involve politicians, agencies, business interests, individual interests, academic interests, and so on. And so the example you gave of the governor saying we're not going to let fires burn anymore was a political decision, right?
Mhm.
There are cases where there are political decisions made that influence the insurance industry or manufacturing or whatever it happens to be. So if you ruled the world, if you didn't have to deal with any of those competing interests, what's the one thing that you would, and now you can see why it's a happy hour question, right?
Yeah.
What's the one thing that, if you could choose, what's the one thing that you would impose or allow to happen, or, and maybe I'll just leave it at that.
How much funding would I have?
As much as you wanted.
Okay.
All right. Well, let's thank Kate one more time. Thanks everyone for joining us and for your great questions. And so nice to see so many people from different generations of San Jose State here today. And for those of you who are able, the happy hour link was sent around. It's the same one we've been using all through the semester. So if you want to join us, please do. Thanks again, Kate, and thanks everybody. Awesome. That was really good. Looks like there are a couple of great talk and wonderful. So nice comments too.
And so does this roll into happy hour, or is that
It doesn't. No, I'm going to close it down now. And then you should see a link in your email that I sent right when the talk started.
Sounds good.
All right.
Okay.
Yeah.
Bye.